YouTube channel. In this video, I'm going to show you on Form 5, Chapter 2. It's called Linear Law. Linear Law, Chapter 2, Form 5, SPM is basically make use of the non-linear equation and transfer into a linear equation. Now, before we get into that, there would be a few things that to catch up. Now, first of all, you can see from here would be a Cartesian plane with a line drawn with the data. In red is the data you obtain in the experiment. In order to draw a best fit line, they call it a best fit line. Best fit meaning what would be the straight line to represent all 5 data? I repeat, best fit would be what is the line to represent all these 5 data. In order to obtain that, all your data must be drawn balanced, meaning it means one will be off, go up, away, go up, another is comes down. You doesn't want to balance it the other way around, so that one is exceeded, go up, one is come down. So you balance this would balance with this one away from the data. So this will be the best straight line. This line represents the overall data. Okay, in this Cartesian, well, I would say this is 0. I will label going to the right. This is a positive x direction, positive x to the right. Going up is my positive y of x. Based on what we have learned, or the intersection of this best fit line over the x is called intersection, we label as C. Y-intercept. T. Y-intercept. It is crucial to know the y-intercept because in order to get the equation of the best straight line, of your best fit line, will always be y is equals to mx plus c. In order to know the c, you need to know what's the interception. Whereas for gradient m would be the changes of y, meaning it is y2 minus y1 over x2 minus x1. Over here, this equation, the denominator is a change of y, or we label as change of y, and then this term, denominator, is actually the change of x. y2 coordinate, subtract y1, x2, x1. If the graph goes up, left to right, it will be positive m. In the event the graph comes down, it will be negative m. Later on, we will have a chapter, we will do more on this. Now, in order to get equation, one should know that in order to get y equals to mx plus c, all you need to do is make use of the equation in our gradient here. Say for example, in the event that you were given in some questions where you were given positive x, positive y, 0. If you're told the y-intercept here is 2, this coordinate is when x is equal to 0. And you were also being told that it passed to a point 6, 4. In order to get the equation of a straight line, all you need to do, equation of the line, sorry. You know of a y-intercept, you know of a point. All you need to do is you substitute the equation y equals to mx plus c. Your c would therefore be 2. In order to get m is therefore, this is, I would define this as y2. This is my x1, y1, x2, y2. So therefore would be 4 minus 2 over 6 minus 0. That would be 2 over 6. Therefore, my equation y equals to 1/3 x plus 2. This is one of the example that you were given an equation, you were asked to look for an equation. In this chapter, question will be given in a graph form, that we can't do it over here, but the concept would be very straightforward. Says, for example, they ask for x when y is equals to 2. Now, x when y equals to 2, all you need to do is, what's the value when x, maybe I doesn't want to use this value, it's very confusing. Value of y, value of x when y is equals to, say, 3. Meaning, when the value here says is 3, what would be this value? Okay, what would be the corresponding value? Now to do that, you need the equation. So what you do is you need to use the equation y is equals to 1/3 x plus 2. You substitute y is 3 into here, and you solve for this equation. Then 3 bring it over. It's 1 equals to 1/3 of x, and therefore your x would therefore be 3. So this value would be 3. Okay, the ability to look at the graph and look for the value is one of the requirements. And next example would be what happened in the event that you were given only 2 coordinates without knowing the y-intercept. Over Cartesian, this is my positive x, this is my 0, going up from my positive y. You will given an equation says, you're given a straight line that doesn't pass through the y-intercept, 2 point A, that would be my 2, 3, B would be my 6, 8. Equation of the line, equation of this line, In this instance, you doesn't know what's a y-intercept, and again, you make use of the gradient equation in the previous page. Over here, it will be y2 minus y1 is equals to, oops, sorry, I think I'll put it the other equation. You may still make use of the previous working. First of all, y is equals to mx plus c. Your gradient m is equals to 8 subtract 3 over 6 subtract 2. That would be equals to 5 over 4. Since this line passed through these 2 points, so you may make use of either point and substitute into this equation. At a point 6, 8, when y is 8, x is 6. So therefore, 8 is equals to 5 over 4 that we found, 6 plus c. This is when you look for your c. Therefore, your c would be equals to 8 subtract 15 over 2. Therefore, my c value would be half. This is 7.5. And therefore, my equation, it doesn't answer the question. To answer the question, my y will be therefore 5, 4x plus half. This is one way of doing. Okay. Alternatively, you may make use of the equation f y equals to y2 minus y1 over x2 subtract x1. The denominator, you bring it up, y2 subtract y1 equals to m times x2 subtract x1. You may make use of this equation and then you still give rise to the same method. I'm not going to talk about this because we will definitely come to this kind of question in the following chapter. We are going next. We will do the linear law, because this is a main question about linear law. So that's the basic knowledge that one should acquire before we proceed. You may try this. Oh, okay. When you have time. Next, what we're going to do is to find how to convert a non-linear into a linear equation. One shall stop by here. You should pause this video. If you have downloaded it from online, you may pause this video and go through questions that enable you, your homework, in your self-study, maybe in your homework. Over this part, first, one shall be able to draw a line of best fit, a best fit line. And then gradient, determination of gradient. Third would be the linear equation to determine the linear equation. your best fit line. Okay. As a kickstarter, to start off with, you should be able to draw a best fit. You need to have a table. Build a table. This is where you have a table, your x value and your y value. You should have your table. And then from the table, a graph paper, one shall label your y 0 and your positive x, and then you should have your data, and then followed by a best fit that will be able to balance. No, it's not a straight line though here, but that's the concept behind it. One shall also take note, if you're drawing best fit, make sure you click to here. You'll be able to find out what's the y-intercept. It's important to get the y-intercept. C. What's the value? And once you have Excel, that part, you may proceed to the next session. Our next session would be the essence of this chapter. Part 2, or I would say is part 2. I only have one part for this chapter. This is from how do you get a non-linear into linear. If you have followed my Form 4 Chapter 2 quadratic equation, non-linear will be those you have a curve, maybe it's a curve up, curve down, doesn't matter. How to convert this equation into a linear law? Using a linear equation into a straight line. There's a method. Now, before I start off with, I would like to define my symbol. What you see on the left will be a small x. I will try to do it a curved x. Whereas once you convert into linear, my x changes. It's a capital X. The same goes with your y, capital Y, and this is a small y. I will talk about it later. Now, to start out with, first rule, what's the first rule? There's not much of a rule. It is your main intention here is to convert non-linear to linear. Some practice exercise. Example, linear will be those with y is equals to mx plus c. Non-linear will be anything but this, y equals mx plus c. Say for example 1, a simple one, y is equals to maybe 2x cubed minus 5x squared, unless otherwise specified, meaning unless the question asks for a specific type of linear question. Otherwise, a good practice to it would be, you may, in order to get into linear, y equals to mx plus c. This is important. In order to get this linear, you are going to have a constant number. Over the part 1 of this video, you should be good at it in order to get a constant c, which is the y-intercept. Constant c is just a number, meaning what does it mean? It is a number, just a number, without the variable of x, not y. Now, if you examine carefully, what you see over here, over the left, is x cubed, x squared. Which one should be made to be the constant? It depends on the question. Okay, depends on the question. So you may divide both sides with x squared. You want 5 to be my constant, so divide both sides with x squared. So therefore, yx squared equals to 2x minus 5. Right? I divide both sides with x squared. Why is x squared? Because I want to make this term to be a constant number. So therefore, it's a constant. To rewrite this equation, therefore, this is my capital Y now, is equals to mx plus c. To compare with this equation, therefore, my capital Y would therefore be my small y over x squared, while my x is actually small x, and therefore gradient m is 2, with your intercept is equals to -5. Now what does it mean by unless otherwise specified? This is a kind of a term that you need to really be careful. Sometimes you need to ask which one should you make constant. It depends on the question. You may of course divide both sides with x cubed, but the answer will be the other way around already. Let me give you an example. Over the question in SPM, you would have question like this, the following. Given in the question, given Cartesian, this is small x, 0, small y, would have a line without knowing the y-intercept. This is this graph is not plot over graph paper, but just an ordinary piece of paper, so you will not be able to scale it. Okay, this is a question given. You were told that this line is related by the equation py small y is equals to x plus q over x. Oh, sorry. You were told in the question this is actually x squared. And sorry, this is xy. Okay, this is given. So it gives you some hint from the question. This hint told me from here I know that my x has to be x squared, my capital X has to be x squared, my capital Y has to be xy in order to get this linear. So here would be my capital X, this whole term would be my capital Y, this whole term. Right? So in your mentality, in your working, y equals to mx plus c. So you would want your capital Y should be xy would be equals to m. Capital X is actually x squared plus c. So it's important to differentiate, to define your symbol correctly. So this is what you should have in mind. In order to solve the following question, this is given, you will ask, find the value of PQ. Find P and Q. Right? In order your hint would be your xy over here. So this is my y. So in order for this to be an x, all you need to do is you times both sides with x. You multiply both sides with x. You multiply by an x. And you multiply by an x. Okay? To do that, oops, sorry, you're not supposed to multiply with both x, otherwise you wouldn't get that. Oh yeah, okay, I can do that still. Multiply both sides with x, so I would get a x py is equals to x times x squared, and then times with the whole term inside here. That would be x squared plus x and x would cancel off, q. What you have in mind is xy without p. You divide both sides with p, so therefore xy is equals to 1 over p q over p. This would be the number with a y-intercept. Now from here, I would write 1 over p x squared instead of x squared over p because this term is my gradient. This term would later be gradient. Is a good practice to separate them so that you know this is basically m. I have my x squared already, I have my xy already, c is my p over q. So things would be much more simpler now because in order to get p and q, all I need to do is to find out the gradient. So from the equation above, gradient equals to 28 minus 16 over 4 minus 1. So my m would be, therefore my m is equals to 4. If I know my m is 4, therefore 1 over p is equals to 4. Therefore my p is equals to 1 quarter. A quarter. I hope you will be able to find out what is your q. Now, getting q would be a little bit tricky because now you need to make use of either coordinate. I would choose a smaller number so that it will be easier to substitute into this equation. To do that, it's very important to do that. Now capital Y is 16. Capital X is 1. You do not use 1 times 16 so that you get xy. No, it's not the case. Xy is the whole capital Y. That's why my y is 16. This is important. Think about it. Take some time. Think about it. This is capital Y here. This is capital Y. Capital Y. This is my capital X. You do not confuse yourself with the small x and small y. Why am I going to do that? So that I will be able to find the C. So therefore xy is 16. So 16 is equal to my gradient. Gradient is 4. X is 1 plus C. So therefore my C would be 12. And this is equals to Q over a quarter. So therefore my Q is equals to 3. You might take some time to have a look at it. Don't confuse yourself. I wish if I could do more on this, but the important part would be here. Most of the time my students get confused with this capital X and capital Y. They confuse capital X and Y with small x and small y. The same is true when you try to sketch or plot a graph where you need to make use of the small x and y to get the capital X, capital Y. I'm going to illustrate that in the following question. It will be the last question for this chapter. I'll take question from, if you leave any question, comment on YouTube. I'll try to help, but no promise. Example number 2. Says you were given a log, question with log, because you can't avoid to have question with log. Given those given in the question is actually precious, x and y. I'll try to sketch it here. 0, 1, 2, 3, maybe have some other number, but for sake of demo, I'm not going to list down everything because you don't have a graph paper. I'm just to show you some hint on how to do it. I mean, you shall practice in your book and look through it. Now, given this is what you have given, you have more number behind it, but I'm not going to show everything. This number you get from experiment, and you were told that you were also told that this data is related by y is equals to hk x plus 2. Now, where h and k, they are constant, and then also it won't stop there. You should continue to read on your question. You have no idea what to do. What is your x and what is y? That's why in the question part A, they will ask you to plot log 10y against, this is important, x plus 2, using a scale of how many to how many in the x-axis and how many to the y-axis, and then draw a best fit line. Now, for this one question, it's rather unique because what you need to do in your answer sheet is, first, you were told, okay, the graph later against, so this is x, small x plus 2, and this is log 10y. Precaution, this whole term are supposed to be my capital Y, and this whole thing would be my capital X, and you should expect it to be linear. Okay, now these are the hints dropped by the question. To do that, relate it with a linear law, y is equals to mx plus c. So since they ask for log 10 and x plus 2, you need to reconstruct. You need to construct a table. You just need to reconstruct because you didn't construct the table earlier. So all you need to do is you have y, no, you have my x, copy from the question. The question earlier you have x, one table. I'll try to make it x and y, 0, 1, 2, 3, copy from question 3.1, from the question 4.0, from the question 4.9, from the question 6.2, and so on. Now, you are asked to look for log 10y, plot a graph log 10y. You don't have that. What you need to do, you need to make a new row. This new row is called log 10y. You log 10, base 10 of log 10y, get this value, and also x plus 2. So you expect 0 plus 2 is 2, 1 plus 2 is 3, 4, and 5, and so on. This whole number, this every number, all the number ones are here, all this number represents a capital X, all this number represents capital Y. Okay, once you have a graph paper, if you draw it correctly, when you have a graph paper, all you need to do would get a best straight line that looks, a straight line that looks like this, where by, well, you have a straight line, capital X, capital Y is my log 10 small y. This is capital X is x plus 2. So this is my 0. You get a straight line, best straight line. Next thing you want to do, based on the practice exercise you have done, you should be able to tell what's this C from the read from the graph. We read from your graph. What's a C? Should be a value, and then get the gradient. This is my y2 minus y1. You read from this point and this point. This is my x2 minus x1. From there, you get to know your m is equals to y2 minus y1, change of x2, change of y to change of x value. Now, once you get that number, once you solve this, and then you you read from the graph, next would be the ability to convert a non-linear to linear, given y is equals to hk x plus 2. You were told that you need to log y, so this is definitely you need to log both sides. You log both sides. If you go through my Form 4 notes, my Form 4 video, you should be able to solve this. This is a product log, so that would be log 10 h plus, this is k raised to the power x plus 2, so you might bring it to the front, x plus 2 log base 10 k. Then you may rearrange them. And then to compare, I'll do it here, don't mind, with y is equals to mx plus c. So therefore, from the equation here, this is my c, this is my m. Rearrange them, you want log 10y equals to x is x plus 2 plus my c is log 10h. Things will be so much easier because from the graph you relate it to log 10h is c, log 10k is your gradient. That will be you solved this already. You should be able to do it now because you have read from the text, read from your graph. So therefore, log 10h is c, and therefore h is 10 raised to the power of c, right? And then log 10k is my gradient. Log 10k is my gradient from your graph. Therefore, k would be 10 to the power. K is 10 raised to the power of n. You obtain from the graph, and then eventually you get the number for h and k. Well, I think that's all. You need to more practice from your books. Again, this is what I meant by unless otherwise specified, because here that specifically says my y, capital y-axis is log 10x, capital X is my x-axis is x plus 2. So this is what it meant by specify. You need to look at the question in order to determine which is the constant for y-intercept. Well, I hope my video is helpful. Do subscribe to my YouTube channel, like my video, and do share with friends over your social network. It helps other people. That's the main intention of this video being made. That's all for now. Hope to make more video in future. Thank you.